Look at the duty cycle for a 555 clock or a 555 Astable circuit. So this is the schematic for that circuit. You can see that it has two resistors and a capacitor. It also has a small capacitor on pin 5, but that's just a smoothing capacitor. The ones we're concerned with mostly are R1, R2, and the capacitor there on the left side of the schematic. So an astable circuit generates a pulse like this, where the up time is what you would consider the on time. So this portion here is T on, and the part down here where the pulse is low, that's the off time. The period would be from the part where it goes on till the end of the off, where it starts repeating the cycle again. So this would be the period T. And for the given circuit, the time on has a formula of 0.7 times R1 plus R2 times the capacitor. The time off is 0.7 times R2 times C, the capacitor. So the period T would equal T on plus T off. Frequency equals 1 over period, and duty cycle equals the time on over the period. So if we do some of the math substitution here, you would get 0.7 times R1 plus R2, the capacitor, over 0.7 times R1 plus R2 times the capacitor. That's basically the time on plus the time off, which is 0.7 times R2 times C. You can see that some things are going to cancel out. So if we have 0.7 times the capacitor and just rearrange things here, on the bottom we would get 0.7 times the capacitor, and then that in parentheses times R1 plus R2 plus another R2. So you can see that these are going to cancel out here, and you would just get R1 plus R2 over R1 plus R2 plus R2. So if R1 equals R2, you would wind up just getting 2R1 over 3R1, which basically would equal 2/3 or roughly 67% duty cycle. So here's that same circuit set up on a breadboard. We have two resistors and a capacitor. Each resistor is set to 10 kilo ohms, so the resistors are equal, and the capacitor in this circuit is 1 microfarad. So you can see over here on the oscilloscope that the on time right here is roughly twice the amount of the off time. On this digital oscilloscope, if we press the measure button, which gives us the statistics, we can see here that it's calculating a duty cycle of 66.6%. So that is 2/3, just like we calculated. So you can try switching out different component values for the resistors and the capacitor to vary the duty cycle. For instance, if you were to make R1 a lot smaller than R2, you could approximate a duty cycle of 50%.